I don't know what it is. Okay, right, I think I can. Anyway, so I've been working on a wildlife camera with a Raspberry Pi. It's a project that I've been actually putting on GitHub. So anything I'm doing today and which I've done in the past, you'll be able to access it on a GitHub repository. So last time I was setting up OpenCV on a Docker, and I've gone through a lot of issues, right, to get it working, and I finally managed to get it working. And then the next challenge was to basically start looking at the camera itself using Docker, right? Because Docker gives me some flexibilities, but it makes things a little bit more complicated, right? So the issue I was facing last week was that I was not able to actually see what the camera is seeing in real time. And to be honest, when I'm developing, that's kind of important, right? So I need to make sure that whatever I do, I can see it in real time so that I can change my algorithms quite quickly. So I've already done a bunch of things I need to set up my development environment. I already made sure that my files are synchronized in real time from my laptop. So I'm using PyCharm, which is an IDE that I recommend you to use especially if you code in Python. So I have that set up. So whenever I make a change here, it goes into the Raspberry Pi. I need to make sure I set up an Rsync first. Let me do that. Might as well. So I might still have 1 second. It's not supposed to be here. 1 second. I need to get my Rsync from my notes. It's a rather long command. Okay, so here you can see the rsync command that I use to synchronize code from my laptop into the Raspberry Pi. By the way, I see if you have any questions, let me know in the chat. I'm checking it from time to time. So if you want to give any input or make any questions, let me know. So the reason I'm here on Twitch is also to be a little bit more interactive. So I welcome anyone to participate. So I've set up my Rsync. Now I'm just going to run it like this. Oh no, it's not like that, sorry. I need to run something else. This. That's a bit odd. I thought I had set up an rsync. Why is it asking me for a password? Oh, I know why. Okay, I'll figure that out in a second. So I'm just going to add my current key. So I don't have to keep swapping. So I just go to authorize keys and add my authorized key there. I'm going to do it in secret, so I don't want to share the keys. So cat. Okay, so should be able to. Anyway, so I've done it in a way that now I shouldn't have to, I don't need to type in my password, and I really need that for the rsync to work. Okay, so now it's working. So I have an rsync set up, and it's going to be checking for, oh wait, I need to be on the directory, otherwise it's going to Raspberry Pi. Okay, so I'm in the directory and I can just run the rsync here. Right. Okay. Let's keep going. So I was very close last week. So I was able to get to a point where I could see something on the Raspberry Pi. 1 second, I shouldn't show that. Pi at. So if I, well, oh no, and it's not here. Okay. So the actual code here is simple. So docker user command it command. Okay, so if I try and show a clock here, okay, I don't have that installed anymore, so I need to test some other way. So I'm going to my app is here. Yeah, you can see everything. So I'm just going to do Python oh, there's nothing there. Okay, so I was trying to run this one, but I was getting some problems, some errors. Unable to access private resource. So this is the error I was getting. Okay, so I have to fix that. And to be completely transparent, I spent a little bit of time on the side trying to figure out what the issue was, and I solved it. So I'm just going to go back to my notes and I'm going to fix that. Just have to check. Okay, I found it. So the issue is, I think it's in the Raspberry Pi. I think it's, I need to run this xhost local plus local. Oh, oh no, I need to do this. So if I do that, I should be able to run. So I can run the program. So I'm actually running the OpenCV program, and you can't see that because it's very dark. But this is actually an image from the camera itself. So this program is now working. So I'm able to take a picture of the camera, and it's very dark where the camera is. I'm just going to switch on the light and see if that helps. Okay, so it's a bit more bright. Just have to, it's a bit awkward here, so I need to be careful. So I'm going to try and run this again. So it's very good because I already can run. It's not amazing. Okay, I'm going to switch on everything. Maybe take away. Okay, so let's try again. Okay, much better, right? Wow, in theory. It's very dark, the image. But that's because of the settings we have in the camera itself. The exposure and things like that. Okay. So what can I do? Actually, I don't even know if this is real time or not. Let me just check. Well, it doesn't seem to be. So this is just taking a picture. Okay, and we can have a look at the code. This is very rough right now. Don't be discouraged by the quality of the image. This is just our start. So here we can see this wasn't working last week. I don't know why. It wasn't working, but now it works. I don't know why. Okay, so BGR is a format of capture. This is actually an. This is interesting because if I put RGB, this basically controls the way you the colors are stored. So we're assuming that, for example, here we assume that red comes first, green comes next, and then blue. And the other, just now BGR was the opposite. So it's to do with the order of the colors, how they are encoded. So we normally know that depending on, well, I think the camera will tell us. Okay, let me close this. This is just a single image, yeah? Not like a stream. So it takes an image and then shows it on the screen. Okay, so this is much worse because I switched off the lights again. So I might actually want to move the camera here so I can do a little bit more. I can play a little bit more with it. I think that might be the best solution. Okay, so let's do that. I'm going to have to switch this off, unfortunately. Why am I still hearing myself? Okay. Okay, but one second. Okay, let's try again. You can see, anyway, the colors are inverted. So this should be the correct way. Okay, I need to switch off. I need to close this window. Oops, what happened there? Stop working? Okay. Anyway, it's very bad quality there, but okay, this is one image. Now I have another piece of code which allows me to see a stream of images. Let's try that one. Example 3.py. I wish I could make these characters a little bit bigger. So you can see. Zoom. Command Shift. Ah, this is not a zoom I was thinking about. What kind of zoom is that? You just have to increase the font size. Let's do 16, 18. Okay, much better, right? Should be able to see that. Right. So this piece of code is going to actually capture a stream. So I'm just going to try it in the Raspberry Pi. Wrong command. So I'm doing Python 3 now. The example 3. Ooh, this looks a lot more bright, right? It's of course it's in the wrong place. I'm going to have to switch off the Raspberry Pi and I'm going to move the camera here. It's much better for all of us. So we can play around with this. Okay, so I'm going to exit the Docker container and power off. Okay, I'll be back in a second. Okay. Oh no. All right, this is going to be awesome. Sorry for all the noise. I'm kind of busy here underneath the table, putting wires through. Just right. So I have my Raspberry Pi. This is my Raspberry Pi. It looks a bit scary, isn't it? My Raspberry. This is a Raspberry Pi 4 with 4 GB of memory. Okay. I'm going to make him face me. And I'm just going to have to connect again to the Raspberry Pi. All right. Nice. Okay, so I'm back. I mean, the Raspberry Pi is back. Not me. I'm here. I've been here all along. So, well, we are back in business. I'm just going to open a terminal. Oh, the zoom didn't. Going to do a zoom. Zoom in. Okay, so you can see very well. Let's see what Docker containers we have running. It's a bit slow. Okay. So it's just started the camera. But I know I have to do some extra setup now. Because oh, it's actually okay. Let's see. I have to do the same xhost local. By the way, I've bought a new Raspberry Pi camera, and this is the Raspberry Pi Camera HQ. I haven't actually opened the box, just because I thought it would be nice to share this moment with you. So even though I have a very, very dodgy camera here, this is going to kill it. This is going to blow it away. Okay. Okay, right. So I'm here a little bit out of, so you can see even my green screen. I didn't want to share that. At least I would. Okay. A second. Just trying to make it a little bit more vertical. Okay. Wow. Okay. Oh no. Sorry for the mess. Just have to. It's quite fast in terms of response times. So even though I'm using, oh, it's okay. Just maybe I need to use some hot glue here because it's okay. It's just stable. It's okay. It doesn't have to be perfect. So I will be able to do some things with OpenCV. Okay, so you can see it's definitely working. Okay, so right, this is a good thing because now we have OpenCV working, and we can do some very interesting things with OpenCV. So let's cook for a small recipe, something simple that we can just start getting used to OpenCV. I mean, there's so much stuff you can do with OpenCV. And it's used mainly for machine vision, even for like driverless cars. What happened to my image? I'm just... Okay. OpenCV 5. This is actually released by Intel. Anyway, I've given up on. So I don't really want to buy a course right now. Okay. Let's try some cool stuff with OpenCV. I'm not going to go into a lot of details just yet because I'm just trying something more interesting. One thing that I've tried before is edge detection, and it's actually creates some very cool images. So we could try this. Yeah, let's try it. Why not? And you can try this at home because I'm going to put all of this in GitHub. With a Raspberry Pi, you can try this. It's awesome. So let's see. New file, edge detection.py. Just copy and pasting code. And I don't know if I need to install Matplotlib, but it didn't have to show this. I didn't have to use Matplotlib, but okay. So let's see what happens when I try to run this. Oh, okay. I can do that for now. I'm just going to install Matplotlib here on the, oh no, I'm missing the install. But I'm going to also do in my Docker file so I don't forget it. Because if I don't put that in my Docker file, whenever you build a container again, you will have an error. So let's do it here. Go to the Docker file, and I'm just going to add. I always add it to the bottom, so it doesn't. I've gone through this nightmare of trying to build OpenCV from scratch. It takes hours, so I'm going to just put this at the end, so it doesn't have to rerun all these layers here. So each line is a layer in Docker. So the advantage of having everything in layers is that you don't have to rerun every single command in the Docker file every time you change the Docker file. Okay, I need to do something for the benefit of my, 1 second. So it's installing Matplotlib. It takes a bit of time. Still running. If you have any questions, feel free to ask. I'm getting bored here. But maybe we can just do a little bit of Canny Edge Detection. This is cool. I mean, I really encourage you to play with OpenCV because you'll be blown away by the things you can do. Look at this. So taking this picture of who I think is Messi, you can actually, you can just draw the lines. And why are we drawing the lines here? Why is OpenCV doing this? What is this algorithm all about? This is to do with trying to recognize something, the shape of something, and it helps. So okay, so right. I have a book which is a very good book on machine vision. Let me see if I find it. I have to find it somewhere. Oh yeah, I have it here. No, not this one. Okay. I can't find the book, but Okay, so I've installed the Matplotlib now. I can try the example, see what happens. So there's an error. So let's see what it is. Okay. Which line number? 634, line 8. Oh, it's assuming, oh, I see. It's trying to get an image that doesn't exist. I can do, let me see if I have double get here. Yeah, okay. I'm going to try first with the image from Messi. I'm just going to copy and paste. Copy image address. Just to see first what it can do with this image, and then we try to convert this to video. Okay. Okay, move. Oh, I misspelled Messi. Obviously, I don't watch enough football to know how to spell his name. Okay. So it's telling me that because this is a non-GUI backend, it cannot show the figure. I need to change the backend. I've had this before. So let me just figure out what to do here. It's going to be fun, I promise. I'm joking. Matplotlib. Python. Arc backend. Obviously, I don't remember by heart, but I remember having an error like this. Excuse me. Okay. I'm just going to add this. Let's see if it works. Okay, I did that before the import. Not a big deal. Can fix that. Well, hang on. So I need to import first Matplotlib itself. Okay, what a fun I'm having right now. Installing missing packages. I'm going to add this to my list once I know it's working. What? What? Okay, I'm not sure what this error is about. Let's see what it is. Okay. Okay, maybe I need to use this instead. I'm already root, so I don't need sudo. Right? I'm going to okay. So now let me just see if I can. Oh, nice. Okay. So I've got something working. But I picked up the wrong image. This is the only image I should. Okay, no big deal. So I'm just going to save. So I've done in the Docker file, I need to change something else. So I need to have this as well. I'm going to put in the same line, so it only creates an extra layer. Because they are both related. And I always have to put run when I'm trying to run a command inside the Docker container. So this is good. I've managed to get some results. I'm just going to try and get the image on its own from here. I think they have, I don't know where they got this image, but you got the point, right? So maybe I don't have to do that. So let's go into this example. So we have this example here. And I'm going to take this example. I'm going to rename this, call it static. And I'm going to create a new file called Edge Detection .py. And this is going to be a more interactive edge detection using the video camera. Okay. This is the original code we had. And I have the image here. So instead of just giving it straight to the IAmShow function, which actually shows the image in a pop-up window that we saw, I'm going to try and run this here without. I don't even need Matplotlib actually. So let's see what it's doing here. So it's showing the original image as a grayscale. I think. And then showing the new image, which is the edges. Edges is this one, okay. So let's see. I'm quite excited about this, to be honest, because this is going to look awesome. You can see me like a drawing. So image, okay, frame. Okay, so you see here, so I'm using the Canny image. I don't know about these measurements, whether I need to check what those are. But for now, let's try as it is. This is probably width and then height, or height, width, I need to check. But let's just give it a quick run. I'm always impatient. I don't know about you, but so Python 3 edge detection.py. Wow. You probably can't get much of what this is, but this is me in drawing. Actually, there's a good way for us to know. Okay. So this, okay, let's try and see if we can work with this. Because it seems it's detecting edges, right? Which is what it's supposed to do. And now it's time to understand this function a little bit more. So first argument is an input image, second and third are the min val and max val. I don't know what. Third argument is aperture size. Okay. So I'm going to do one thing, which is I'm going to show both the original frame and the actual image, that the edge detection. Let's do that. As you can see, here is my actual image, and this is the edge detection. And what I want to do is to try and see if I can do a better job. Okay. Okay, I want to improve this. Let's see. If I make this, I'm still not sure exactly what is mean, and I need to, okay, let's try first, and then we go a little bit into the theory to see if we can make sense of this. Canny Edge Detection is, it's worth to understand things. Okay, so it seems like I've made things a bit worse. So let's see, if I make this smaller, does it make it better? Oops, I get these errors from time to time. Okay, what is that? Okay, can it actually detect? Oh, you see, can detect my mobile. You can see my face. Yeah, this is not the best camera, right? So the results here are probably not as good as they could be, right? So we get into a point where it actually starts to make more sense. Let's decrease this value and see what happens to 100. Wow, okay, this is cool. So what we've just done here, yeah, it's very cool, isn't it? And this is actually very little effort. This is an algorithm that is used in machine vision for, from what I understand, also used for detecting edges in a road. So for example, if a car is trying to drive through, it knows where the road ends and where it starts. So it has a lot of applications. It's also using AI, not the deep neural networks, but for things like in OpenCV, there's like ways to identify objects using this type of edge detectors, which I'll go into more detail at some point. But this is very cool. You can see my camera is actually not that good. It's not very well focused, but you know what? This is cool. How awesome is that? Yeah. Okay, so I've done. Let's see if I can get this even better. Wow. I mean, this is the fun part. Until now, I've been like setting up, installing packages. It's not fun. So 50. And I think we should do a little bit of reading up on the algorithm. Wow, okay, it seems like it's getting better and better. So for me, it seems like the lower values are better. Cool. It's awesome. So I can do a small video clip and put on YouTube, and I think it's going to be popular. Yeah. And you can do too as well. You can actually just download my GitHub repository and you can do the same. All right. Okay, I shouldn't get too excited. Let's do a little bit of the boring reading, but I think if we read this, we're actually going to get something out of it now, because it is quite special. Canny Edge Detection is a popular edge detection algorithm. You know what? It's just because I'm having fun. I just want to make sure that you also see this. In fact, I'm going to do it here. Let's open a browser. This is a Raspberry Pi 4, it's a small machine, and it can do all of this. So I'm going to copy the URL. Okay, right. So let's learn. Okay. Canny Edge Detection is a popular edge detection algorithm. And to be honest, I need to make it bigger. What is the menu for this? Zoom. I don't know about you, but I like to see big letters. Okay. So Canny Edge Detection is a popular edge detection algorithm, and it was developed by John F. Canny. So hence, okay, now we know why it's called Canny Edge Detection. So there's a few things that we need to understand. So it was developed in 1986, I was born not long before that. It is a multi-stage algorithm, and we will go through each stage. First one, noise reduction. Since edge detection is susceptible to noise in the image, first step to remove the noise in the image with a 5x5 Gaussian filter. So it's actually telling us that we should remove some noise from the image, but I haven't seen that in the code. No, we didn't do that, but I don't know if this algorithm does it automatically for you. Finding intensity gradient of the image. Smoothed image is then filtered with a Sobel kernel in both horizontal and vertical direction to get the first derivative in horizontal direction and vertical direction, so gx and gy. From these two images, we can find edge gradient and direction for each pixel as follows. Sorry, you're not reading this properly, right? Am I on the way? going to show it here. Okay, right. I have to say this is very cool. Okay. Okay, so this isn't a complicated, it's not very complicated actually. The square root of gx square and plus gy square. So that's the edge gradient, and then it calculates an angle using the inverse of the tangent. So gradient direction is always perpendicular to edges. It is rounded to one of 4 angles representing vertical, horizontal, and 2 diagonal directions. After getting gradient, magnitude, and direction, a full scan of the image is done to remove any unwanted pixels, which may not constitute the edge. For this, at every pixel is checked if it is a local maximum in its neighborhood in the direction of gradient. Check the image below. Right. You can see like my hands, you can actually just detect the edges, right? Okay. Point A is on the edge in vertical direction, and gradient direction is normal to the edge. So it's showing a vector here. Point B and C are in gradient directions. So point A is checked with point B and C to see if it forms a local maximum. I'm sorry, I'm just trying to understand what I've just read. What's the local maximum? So if I go to this equation, okay. I think I will probably need to read up a lot on this to understand it fully. Okay, if so, it is considered for next stage. Otherwise, it is suppressed, but put to 0. In short, the result you get is a binary image with thin edges. Hysteresis thresholding. This stage decides which are all edges are really edges and which are not. For this, we need 2 threshold values, min val and max val. Any edges with the intensity gradient more than max val are sure to be edges, and those below min val are sure to be non-edges, so discarded. So that's what I was playing with, min val and so that's why when I increase the max val to a bigger value, it kind of almost showed nothing because the threshold was too high, because it tries to get, it considers an edge something bigger than that threshold value. So it starts to make sense. So those are the 2 values I was controlling. So anything below min val is not an edge, so it's discarded, and anything above max val is definitely going to be an edge. But what about in between? Those who lie between those 2 thresholds are classified edges or non-edges based on their connectivity. If they are connected to sure edge pixels, they are considered to be part of edges. Otherwise, they are also discarded. See the image below. Max val and min val. The edge A is above the max val, so consider as sure edge. Although edge C is below max val, it is connected to edge A, So that also considered as valid edge, and we get that full curve. But edge B, although it is above min val and it is in the same region as that of edge C, it is not connected to any sure edge, so that it is discarded. So it is very important that we have to select min val and max val accordingly to get the correct result. This stage also removes small pixels noises on the assumption that edges are long lines. So what we finally get is strong edges in the image, which is what we have right now. It's the keyboard. You can see it. It's cool. So OpenCV puts everything that's described above in algorithm into a single function, cv2.canny. So the first argument is the input image, the second and third argument are the min val and max val, and the third argument, which I didn't specify, is the aperture size. This is kind of, aperture is normally used to control the light amount, if I'm not, yeah, how much exposure you get. By default, it is 3. Edge gradient, okay. Okay, so we just saw this. What wasn't very clear is that if it's doing the Gaussian blur as part of the cv2.canny. I think it might be doing that. A Gaussian filter. Does it actually do that automatically? It's a good question. Let's find out. I'm just curious because if I need to, in this case, I'm okay with this image because it's not very noisy. Make this kind of cv2. Okay, this is a question I'm asking just now, and someone already asked on Stack Overflow. That's why I love Stack Overflow. I know it is important to apply Gaussian blur to an image before using Canny to detect edges. And my question is, does cv2.canny do Gaussian blur on its own, or is it necessary to apply cv2.gaussian blur before cv2.canny? The documentation isn't clear on this point. I do agree on that. The documentation didn't really specify that. And let's see if there's any conclusive answer. Oh, I like to see the green ticks first, but it seems like there's none. So let's see what he says here. Okay. So actually, my camera itself, this is interesting, okay? So the Gaussian blur is actually used to blur the image because it makes it easier to detect edges. And you will agree with me that my image quality right now is not very good here. Look, it's actually blurred. So I think I have, by luck, I have a natural Gaussian blur. So what this answer is saying here is that if you use the default value of aperture, which is specified, it's going to use, the default is a 3x3 kernel, so which means that no kernel is applied. Okay. Sorry, no Gaussian. So if you use a 3x3 kernel, I'm not saying that correctly. It says here, if you use the default value for aperture, it's going to use a 3x3 kernel, and no blurring is applied. So in this case, I should actually do a Gaussian blur to make it easier for detecting edges, right? But if I change the aperture to something like a non-default value, it will actually apply the blur in the source code, which is a bit odd. And there is a link here. I don't know if it's the same link I was on. This is a C++ version. Okay, but there's also Python. Let's see the Python. So this example here is different from the one I just tried. In fact, the OpenCV version seems to be a bit different as well. 3.4, I'm on 4.5. It's actually converting. Okay, so it's here. So you see it's doing a blur before it does, I think it's a Gaussian blur, and then it checks for edges. The kernel size here is set to 3. Okay, this is cool. I mean, we've learned something new. We have OpenCV working. We can have lots of fun with it. And I think I'm going to finish off on a high, right? So I have a lot of things to do for the wildlife camera, but I already have OpenCV working. I have TensorFlow. I'm able to see in real time as well whatever I do with TensorFlow or OpenCV. I actually bought a new camera, which I'm going to unbox very soon. And this camera is actually awesome. But before I finish, I wanted to do a small test. Just want to see what happens when I make this camera face outside. Yeah? Oh, you see that? You can see the curtains there. I think if I open the curtains, it's going to overwhelm the camera. Let's see, because it's quite bright outside, and I'm curious if you can see the roof. Look. Wow, you can see this is the roof. So you can see the houses there as well, which is awesome. Oops, like this is kind of, I'm starting to, wow, you can see, I mean, this is kind of amazing. When I get the other camera working, I'm going to have a lot of fun. It's going to be, anyway, this camera doesn't have a great resolution, so wow. And you can see I'm like so bright now because the exposure is very high. Look, I have a tree as well. Let's see how it looks like. Wow. Oh my goodness, this is I think this is beautiful. I could actually do a cartoon with this. I don't even have to do any animation. Let's just use Canny Edge Detection. Okay. So you see a tree there. It's like but it's not very well defined. But I could play with the values as well. So just so you see, it's very, very bad image quality, but you know, I wonder if you can see getting worse. Can you see Canary Wharf there? Look. Your bar can make up. So you see, right? This is awesome. Okay, so I'm finished. I'm finished. I finished on a high today, I have to say. I really think this is a good result, and I can do some awesome things now with this. And you know what? Like, let me just, right. Okay. Can you see me again? So I finished my stream for today, and anyway, so you've seen what I'm up to, and if you want to keep up with whatever I'm doing, don't forget to follow me on Twitch and also on YouTube. And yeah, I'll see you again soon. Happy coding!